Hello and welcome to lesson 2, the tangent ratio. Lesson 1 was just taking notes, looking through. There's no video, so if you're looking for that, you won't find it. We're going to go through lesson 2 together, which is really our first introduction to trig. So here, let's get started. In any right angle, there are 3 different ratios of side lengths. The ratios of side lengths will always be the same no matter what the size of the triangles are, as long as the angles have the same measure, and they can be identified as similar triangles. You can review what similar triangles are in the first lesson. One such ratio is the side length of the side opposite an acute angle of the length of the side adjacent to the side of the same acute angle. This is called the tangent ratio. In terms of labeling sides, opposite, adjacent, and hypotenuse, if you'd like to review that, you can look over lesson 1 notes. For example, in the triangle below, the tangent of angle A can be written as tan A of the ratio of the side opposite of angle A to the side adjacent. In other words, we have this formula here. Tan A is equal to opposite over adjacent. So this is solving for the angle. And these here are the side lengths. And this formula will be very helpful for us as we solve this. So if angle A, notice how it's a capital letter, is an acute angle in a right angle triangle. And notice how it says right angle triangle. It has to be a right angle triangle to use these formulas that we're going to be working on throughout this trig unit. Example 1, find the tangent ratio. Determine the ratios of tan D and tan F. So we're looking at the angle in 2 different viewpoints, as I like to think about it. So the first one, we're going to start at the tan D. So we know that tan D is equal to the opposite of D divided by the adjacent of D. So we look over at our triangle. Opposite is always directly across and adjacent is always directly beside. So we'd say tan D is equal to 3/4. Now let's look at tan F. So we're looking at the triangle from this viewpoint at letter F. The tan of F is equal to the side that's opposite F over the side that is adjacent F. So in this case, opposite is 4 and adjacent is 3. So it's 4/3. And we call this side here, which is not used in the tan ratio, but this is our hypotenuse, and that's always found directly across from the right angle. When using trigonometry, you need to remember the following 3 steps. Label the triangle fully in terms of their sides, choose the ratio based on the information that you have, and then solve for the unknown using a calculator. You will require your calculator throughout this unit, so make sure you always have it. If you're given the tangent ratio of an angle, you can find the actual angle measure using a calculator. To do this, you need to work backwards using the inverse tangent. So that's represented by tan with the superscript -1. You can find that on your calculator, usually by pressing the Shift tan button, Shift plus tan, which will give you inverse tan, or second function button, plus tan. So written right above it is usually the inverse. So find on your calculator how to get the inverse function. You can practice that to confirm that you know how to use your calculator by finding the inverse tan to find theta. So if we have our calculator, this gave us a value here. Access the inverse tan, open bracket, 4.356, close bracket, and that equals 77.1 degrees. So use your calculator right now to make sure that you can get 77.1 as the inverse tan of 4.356. So that's how to solve for the angle. Now let's use the tangent ratio to find the angle measurements. Determine the measures of angle G and J to the nearest 1/10 of a degree. So let's solve for angle G. I'm going to show my work over here. Now the formula tells me that the tan of angle G is equal to opposite over adjacent. So I'm going to look at my triangle. Here's G. Opposite is 4. Adjacent is 6.4. Oh, sorry, not 6.4. That's the hypotenuse. The hypotenuse is always found directly across from the right angle. 5 would be our opposite. So tan of angle G is equal to 4 over 5. Now I grab the calculator and I want to solve for what is the inverse of 4 over 5. So inverse tan, open bracket, 4 divided by 5, close bracket, equals 39 degrees. Now I have angle J. So I'm going to orient myself from angle J. It is always opposite over adjacent. So I have tan angle J is equal to opposite over adjacent. That's O is short form and A is short form. So tan of angle J is equal to 5 over 4. Now because I'm solving for the degrees of the angle, I need to do inverse tan of open bracket 5 divided by 4 close bracket. This would give me 51 degrees. Example 4. Using the tangent ratio to determine the angle of elevation. Here we have solar panels on a roof. They work best when the angle of elevation of the roof is approximately equal to the latitude of the house. The angle of elevation is the angle formed by a horizontal level at eyesight and the line of sight to the object above the horizontal. So here we have the angle of elevation. Now it tells us that the latitude in Fort Smith, Northwest Territories is approximately 60 degrees. So determine whether this design for the solar panel is best for Fort Smith and justify your answer. So we need to determine how many degrees is the angle of elevation here. So this is what we want to solve for. Now we see that this is a right angle, so directly across from it is the hypotenuse. And we're going to use tan ratio. So tan theta is equal to opposite over adjacent, which in this case, opposite is always directly across from the angle. So the opposite is 9 over the adjacent is always right beside 12. Now in solving for an angle, you need to use inverse tan. So we have theta is equal to inverse tan, open bracket, 9 divided by 12, close bracket. This gives us the angle of elevation as 36.9 degrees. Now, in this case, it tells us that the angle of elevation should be the same as the latitude, when this case is 60 degrees. So therefore, the design is not close to 60 degrees, and therefore it does not work. There we have it. So that is lesson 2 on the tangent ratio. Take a look at the practice listed below in the OneNote to check out how to practice what we learned today.